Yeah, refraction, lenses and side. You are seeing the refraction slide, right? So now already we were discussed about refraction, that is the change in the direction of a wave is crosses the boundary between two media in which the wave travels at different speeds. Now you are seeing in the PPT, that is the light is bending from whenever it travels from one medium to another medium. Very clearly we are seeing here the incident light is incidenting on boundary of the media, and whenever it crosses the other medium, due to depends on its optical density, it is bending towards normal. Now the angle which makes with the normal by the incident light ray is called angle of incidence. The angle which makes by refracted light ray with the normal is called angle of refraction. We know this is a normal. So with respect to that, next, refractive index. Refractive index is defined as is the ratio of refractive index. The refractive index is nothing but the ratio of speed of light in a vacuum to the speed of light in material or in any medium. This with respect to vacuum, whenever we will compare, that we take as absolute refractive index. Otherwise normal refractive index, the speed of light in a medium 1 to the speed of light in a medium 2, we will take as a definition of the refractive index. So that you will see from this refractive index we were discussed in a live class before also, that is second law of refraction, that also gives us Snell's law. Nothing but when a light ray passes from the medium 1 to medium 2, we have the Snell's law is nothing but n1 by n2 equal to sin theta 2 by sin theta 1, or nothing but that also can be written as n sin theta 1 equal to n2 sin theta 2. This n1 sin theta 1 is nothing but the incident light ray which is making an angle theta with the normal. Okay, and n2 sin theta 2 is nothing but the refracted light ray which is making an angle theta 2 in the next medium, nothing but in a medium 2. This is a Snell's law which we can apply in different areas wherever the medium changes, due to that the refraction takes place. We can see here a rough idea about the different materials of refractive indices. Vacuum, if you see the vacuum of the refractive index of the vacuum is nothing but, you can see here 1. Since it is a index, it doesn't have any units. For the air also nearly same, that is 1.003. For ice it is also 1.310. For water 1.33. we also did in a numerical part in a previous videos. Like that, different transparent materials we are having, different materials having different refractive indices. Now in same way, actually a light whenever it passes through prism, you can see here prism you are seeing. So this is also part of refraction, but through particular dimensional object when the light travels, nothing but here it is in a triangular form, equilateral triangle form. So when a white light is incident on this medium, then this white light get disintegrated, I mean will be splitted into its constituent colors, that is Vibgyor colors, 7 colors which we are having. Okay, through that it will be split and it will emit out from the medium. So whenever it will emit out from the medium, then automatically we can find that Vibgyor colors on the screen. So simply we can say that the separation of light into colors arranged according to their frequency and wavelength by interaction with a prism or diffraction grating. Okay, that we can see on the screen. So this is nothing but the incident light ray is splitting, you are seeing here, and it is emitting out. Whenever it is emitting out, you can find that on screen, on any white screen, if you place on that, this 7 VGR colors will form. Not only the prism, if you use any transparent glass medium which is in different direction, you can take out. But if you take rectangular glass, you will not find, because there is no deviation of the light whenever it will pass, so it will not get split. Okay, so the deviation is different in the rectangular glass slab, so it will become different. Now this is dispersion. The word meaning is nothing but when a white light passes through a prism or through a transparent medium, if it will be splitted into its constituent 7 colors, is called as dispersion. This phenomena is called as dispersion. Okay. Now, rainbows. Rainbow is also application of refraction of the light, but in the rainbow there is one more concept also included, that is total internal reflection. Usually in our 10th standard people may not have this concept, but the other higher classes like 12th standard and other in foundation area, they will have this critical angle. Of course, I'll try to explain you what is a critical angle. When a light ray passes from denser to rarer medium, it will make some angle. Therefore, the refracted light ray will make 90 degrees angle with the normal. Then that corresponding angle is called as critical angle. Okay, the corresponding incident angle is called as critical angle when the refracted light ray makes 90 degrees angle with normal. So after that, if you are increasing the incident light ray or incident angle, then automatically the light ray which comes on the surface, and from there it will be reflect instead of refraction. So such phenomena is called as total internal reflection. So usually you can see here the light ray, white light ray coming from the sun. This is a water drop. One water drop we are considering here. On one water drop, when light ray incident, obviously it will bend towards the normal. So bending light ray will travel and will hit here. Okay. So after hitting, it's supposed to transmitted from medium of water to air. But instead of refracting or transmitting from here to here, we can say refracting. So it is reflecting here itself. Why it is so? The critical angle which is between the air and water interface is greater than that. So therefore the light ray which is refracting, instead of, it will reflect in the same medium. So for that the critical angle 42 degrees. More than the 42 degrees, if light ray could have incident, then it will reflect back. So it has reflected back. After reflecting, these light rays which are coming out will fall on a sky, as we will see on a sky as a vijaya colors. Okay, as a rainbow. This is we have drawn with one drop. There are n number of water drops as located after the rain. So infinite number of water drops are available. Through water drops, so many light rays will be go under the total internal reflection process. Therefore, all the light rays contribute a line which is forming as a rainbow on a sky. Actually, the rainbow which forms is entire earth. It will form as a circle. Since we are on the hemisurface, we can see half of the rainbow as a curve only. Okay. That is nothing but we call as rainbows. There is a question here. Sir, always there is a one rainbow only can form, or is there any chance to more than one rainbow can form? Yes, there are the more than one rainbows also can form. Okay. The same manner, whatever the light ray has incident and it went on total internal reflection, it has come out. In the same manner, there is again one more light ray if it comes. Okay, it will be incident if it will go under total internal reflection. Again, while it is refracting at this spot, if the refracted light here it makes incident angle more than the, then it will go again reflection back, again it will be incident, then it refracts out. Form whatever the rainbow has formed before, for that the second rainbow inverted image will form. Means if there is a chance of third rainbow, then third rainbow also will form inverted to the second rainbow. Like that, n number of rainbows possible, or more than one rainbow is possible, depends on the direction of incident of light on the water drops. That you can see the picture of rainbow which is forming as a curve. Since we are on the hemisurface, you can see only the half curve. Actually rainbow completely it will form on the surface of the earth. So next topic, lenses. Okay, these lenses also transparent mediums which is contributing the phenomena of light refraction. So you can see here different lenses we are having, depends on requirement, as we are human beings made as our use in different shapes. Okay, here if you are discussing, this is a bioconvex lens, both sides transparent medium, and this is a plano-convex lens. This is one side plane, the other side is wax surface. And convex concave, this is little wax surface, you can see cave surface, you can see here. Now in this meniscus, both are the same cave surface, combinedly it is forming meniscus. Plano-concave, in this plano-concave, this is a cave surface and this is a plane surface. This completely called as plano-concave. If these two gets combined either sides, we have bioconcave. Usually we will learn the properties of lens by bioconvex and bioconcave lens. We will use how the light ray will be converge and diverge away from each other, we will understand. Usually the lens is converging lens, in the sense we can see here this is a converging lens. Through this converging lens the light rays will be incident parallel to the principal axis. We can say this is a principal axis, as actually we will not see any principal axis physically on the lens, but we will assume through the center of the lens, whatever the line is passing, that axis we are taking as a, yeah. So here all the light rays which are traveling parallel to the principal axis. Actually if it is a lens, in the sense both sides we are having the transparent mediums, the light ray can travel from this side, from this side also. So let us say one side, if we take all the light rays traveling parallelly, it will converge at this lens whenever it has entered from here onwards. Actually in the diagram it has not shown, now it is showing at the center, but from here onwards it is converging and it's joining at one point. Not only one light ray, each and every light ray will bend. Why it will bend? Because whatever the surface you are seeing here, this surface is curved. Okay, when light ray enter from rarer to denser medium, it will bend towards a normal. If you draw a normal here for each case, okay, so it bends here. Here also it will bend. So like each and every light ray will bend towards a normal. After coming here at the edge, it is moving from denser to rarer, so it bends away from the normal. Therefore again it will go like this. So all the light rays contribute and they will meet at this point. That point we called as focus. Okay, we call as focus. What is a focus? Okay, there are some characteristics of lens are available. That is, one is principal axis. Principal axis is nothing but the line which is assumed or passing through the center of the lens is called as principal axis, and the light rays where they will meet in converging lens and where they will appear to meet in diverging lens is called as focus. The length from the focus to this center point is called optic center. Okay, the length between the optic center and focus is called as focal length. That denotes with the small letter. Actually this is with the capital letter. Now the distance, there is one more thing. Double the focus means if you obtain any light ray through this, we can obtain the focus at 2 points. At what distance the focus has formed, double then the distance, double that the focal length distance, there is one more focus will form that we call second focus, or if it is f1 in the sense, this is f2 we will take. Okay, that is 2f distance, 2 times of the focal length distance from the optic center. So these are the basic characteristics of the lens. You can see here there are the rules which I have told you. Any incident light ray travels parallel to the principal axis of a converging lens will refract to the lens and travel through the focal point on the opposite side of the lens. So that which we were discussed. Any light ray traveling through the focal point opposite to the first point. Any light ray traveling through the focal point on the way to the lens will refract to the lens and travel parallel to the principal axis. Means completely it is converged to the first point which you are seeing. Okay. Next, the third rule which you are seeing. An incident light ray which passes through the center of the lens will in effect continue in the same direction that it had when it entered the lens. Which passes through the center of the lens will in effect continue in the same direction. Means whatever the light which passes to the center, optic center, it will not deviate, because at one position, only at optic center position, if you see the light ray which comes in any direction, it will not bend, because at this angle it is acting as 90 degrees. We know that we have studied at 90 degrees angle the light ray will not deviate. Okay, so that is a rule. Now apart from that, you can see here the lens image formed by a converging lens, nothing but concave lens. Okay, so let us say object position is here, that is beyond the 2f. Okay, so let us say if this is object position, the light ray coming from the object parallel to the principal axis, as we know the rule, as per the rule it is bending and it passing to the focus. And the light ray which is passing to the center, optic center, is not deviating, it's going straight, but it is meeting the first light ray which has refracted through the focus. And one more light ray which is passing to the focus, that is also bending at the lens and is traveling parallel. These three rules we were studied before. From these three rules, whatever the light ray refracted, they are meeting at one point. That point, if you draw a line, that shows the image location and position of the image and size of the image also if you draw. Okay, that where it is where it has formed between the focus and 2f it has formed. Okay, this is a one example in a case of converging lens. Now we will see the diverging lens. See, diverging lens is bioconcave lens. In this case, same as if light rays passing parallel to the principal axis, all the light rays is bending away from the principal axis. Why it is bending away? Here, note this point here, the concave shape it is. There it is convex shape. The light ray which is entering, the angle, though it is entering from rarer to denser medium, if you obtain the normal, okay, towards the normal only it is bending. But after coming here, it is bending away from the normal. So therefore the light ray bending away. Depends on the geometric shape the light rays is changing. So since this lens name itself is diverging, means all the light rays diverging away from each other. So they never ever form a real image. But if you draw virtually, if you are extending the light rays back the same side at particular point, they will meet. That meeting position I told just now, the meeting position is called as focus. Means in this case they are appear to meet, actually they never meet. Why this appear to meet, sir? As our purpose, we need to calculate position of the image where it will form. For that purpose we will take calculatively the apparent position of the focus in the diverging lens. Same, all the light rays which has diverged, if it is entered at the concave surface, then they will pass parallel as previous case. Okay, this is diverging lens. Rules for diverging lens, just now we were discussed. Any incident light ray traveling parallel to the principal axis of a diverging lens will refract to the lens and travel in a line with the focal point, nothing but focus. Now, any light ray traveling towards the focal point, means which is coming from the away, will refract to the lens and travel parallel to the principal axis. That was the second rule. The same as third, the light ray which is passing to the center, optic center, obviously that will pass without deviating, means either it is convex lens or concave lens, or diverging lens or converging lens. The light ray which is passing to the optic center will not deviate. Okay, you can see one image diagram. The light ray which is passing from the object is straight parallel to the principal axis, has diverged. Okay, and one light ray which is passing little through the focus, then it can be extended back like this. And the light ray which is passing to the optic center is going straight. So whatever the light ray is going like this, you can extend back, and this is also you can extend back. However, through the same line, it is not deviating, it going straight, you can't take anything, but at this point or at this point it is refracting, they are meeting. Due to meeting position, we can obtain the position of the image. Actually the image which has formed, this is virtual image, that's why same side it has formed. Okay, this is nothing but this type of lens we will use in a case of spectacles, okay, which we need to see or which we need to cover our eyesight and all. Okay, this is nothing but here it has given the characteristics of the image. Automatically by seeing we can see the size of the image has decreased. Okay, this is virtual image since it has formed same by appearing light rays, and that is smaller, and its size has decreased, and the position, when object position is beyond the 2f, the image position between the f and optic center, you can see. By when you have drawn the diagrams, lens diagrams or ray diagrams properly with the proper positions, automatically the obtained image will satisfy the characteristics. Okay, depends on the position of the object. So next, human eye. This human eye we will discuss in the next video with effectively for all my dear students. Okay, for this class, thank you very much, and please share it and like it and subscribe it also. If any suggestions, please welcome wisely. Thank you very much.